Mm-hmm. Doing good. Let me pull up today's exercises. Well, we're getting situated here. How's everybody's weekend?
Enough.
Yeah, email me if you have some issues with your runestone grades that just change. If your runestone grades just change, it's quite possible. I'll be sure to go into through your account and check for it. It's quite possible it got over. There honestly shouldn't be an issue, but I will check your activity and fix it manually if I have to. Okay, so I literally just updated, imported the grades. All right, I'll go through my email. Sorry, I haven't checked it. It's been a bit hectic. It's always a bit hectic. Like you expect it to be busy, you know, you have time to do something else and then something to go through your emails and then something else comes up. All right. So, I feel like the response we got from about Thursdays, the quiz due date was the quiz due date was Sunday, right? If I'm recalling correctly.
Yes.
So yeah, I'm having to sit down. Yes, if you go back and do work, if you go back and do work that's already been assigned, then yes, you will get credit for it. Okay, so let's see. Let's go ahead and let me mute Discord. Yeah, you can also DM me on Discord. Either way works. So yeah, I wanted to do something similar to what we were doing previously for our I've posted our assignments, and I've got an assignment here, or rather, sorry, posting the in-class activities for the day. And let me just go ahead and share my screen and show you. Okay. When was Thursday's exercise due? Just turn it in and I'll check it. Yes, it was. Just turn in what we did for last Thursday. If you haven't done that, check the recording. Okay, and do it on and follow the recording. So today we're going to, today and on Thursday, we will be doing two things that I have in the past given as homeworks. Today's exercises will be some smaller exercises in Python. Now, these exercises can all be completed in multiple different ways. Part of this is that we need to write functions for this, and we're going to do so. The number two, and then the second exercise is about converting. Sorry, and then Thursday we're going to work on converting things into Pig Latin. Next week, once we get to module 7, we're going to kind of hit our crescendo, hit the end of the crescendo of work that we're doing, and we're going to go and work on our hurricane tracker lab, which is one of the favorites there. And yes, technically it's lab 6 because lab 4 was also lab 5. So for lab 6, check and be sure to look at and see that you have the option as to which exercise you want to do. So let's take a look at our exercise for today. So again, this is something I've done as a homework in previous semesters. and it's just simply moved into an in-class exercise. So here I've got 4 different exercises to do, and the grading there is still from when it was a homework. So ignore that. It's worth 30 points for today. So these are different functions that we want to create. And the difference here is that we're typically going to return something rather than just print something out like we were doing for our last functions. So we'll get a value back from the function to use later. So we're transitioning here at this point to stopping using prints inside functions and only using them out of functions. So here's the exercise we're going to be working on today. Number of vowels, which we're going to basically, given a string, count the number of vowels that occur in it. There's a lot of different ways to do them, and I want to go over this in detail as to how to do that. Next is number of even digits. There's an easy way, and there's a different easy way to do it. Sorry, there's a couple different ways to do this one. One is easy and one is not hard, but also just like not as intuitive as the easy way. But it's important to know how that other one works for the other stuff we'll do later. 3-digit Armstrong numbers. We will check if a number is a 3-digit Armstrong number. There's a special type of number for number 3. And then number 4 is something I've pulled from, again, Savage's textbook. Again, this was a Java problem, but problems in intro classes, it doesn't matter what language they were originally intended for, where basically we're going to try to figure out a 4-digit number that follows the following property with these digits. Okay. So let's go ahead, and since we only have an hour and 10 minutes, let's go ahead and get started. I'm going to save this file as, let's go ahead and save it on my desktop. Intermediate.py. And so what we're going to do is we want to write a function called num_vowels, which will, given a string, tell me how many vowels that were in the string. Now, because I get asked this by everybody, Y is not a vowel. The only vowels are A, E, I, O, and U. That does mean that there are some words that do not have vowels in them. So, okay. Oh, chat was not open. So, yep, you are following along with this and submitting it, right? Alex, please send me an email to remind me to fix that later. If you're having issues opening exercises for that. If you are, then you're probably, if you're having issues opening it, it's quite possible you're not the only one. Okay, or DM me in Discord. That way it will be in my queue to fix it. Geez. Okay, so let's go ahead and tackle number of vowels. Now you can find this, by the way, if you want to follow along with the PDF on modules and just in-class exercises loops. So how to figure out the number of vowels? Well, we need to write a function and it needs to return a number. So I'm going to go ahead and start you off by writing the head for the function, and then I'll give you a couple chances. No, it doesn't have to be exactly like mine. I'm just going to briefly check that you did indeed turn something in that looked like you attempted this, as opposed to turning in a blank file. That's basically what I'm looking for. Basically, I'm looking, did you actually participate, and did you not just turn in some utter shenanigan of something? Num_vowels. Text. All right, so that's what I'll call mine. You can call it something else, but and then what you're going to want to do is that you're going to want to complete this function over here and drop it in meeting. You can find this in Canvas. Click on modules, go under module 6, and then you'll want to click on in-class exercises loops.
I have a question.
Yes.
So from last module, module 5, right? Do you know the assignment that we did on Thursday?
Yes.
Yeah, so we didn't finish that whole assignment. Like, what should we do? Like, should we just submit the whatever we did in the class?
Yes.
Or should we just
I would prefer you to finish it, but you can submit what you have.
All right.
Okay, which is on the video. And if you need the completed, it to be fully, the answer is at the bottom. You can use whatever you want for this. There are multiple ways to solve this problem. All right. So I'm going to go ahead and send you into breakout rooms for about 5 minutes to tackle this one. And then I will ask different people for opinions on how they solve it. Let's go ahead and do 130 breakout rooms. One person per breakout. No, that's not going to work. Let's go ahead and make 50 breakout rooms, and that's still too. Okay, there we go. Open all rooms. And let me enable screen sharing too. All right, we'll wait for people to get back in. Okay. Yes, next problem. Oh, no. For the next problem, you're assuming that you are getting you're assuming you're getting an integer, not a string. But let's focus on this one with text. Okay, so number vowels. So does anybody want to volunteer how they did their solution? And talk about their,
I made a list of all the vowels.
okay. And then what did you do?
I initialized the variable vowel count as 0.
Uh-huh. And just talk me through it.
Oh, and then I did like a for loop to go loop through all the characters in the given string.
Mhm,
And then if that given letter was in that list of vowels,
mhm.
I would increment or like add 1 to the vowel count variable. And then at the end of the code, I would return the vowel count.
Yep. So pretty much no matter how you go about it, you're probably going to have something like this, where basically we have a vowel count, which is going to be used to count the number of times it appears. And then at the end, then we're going to do stuff. And at the end, we're going to do return the vowel count, which is how many times it appears. It's what's going to happen in between that we want. And we want to return it as opposed to print it, because returning it means that we can reuse this and we can use this and chain it to a different function call. Kayla, you're still gonna start a holy war. But Kayla brings up a great point, which is that in Java that you learn to do write variables like this, lowercase, and then any words that we attach to like this one vowel count, you do a camel case. But and the textbook uses underscores. Actually, I prefer to do it the way that Java does it because it's less strenuous for me to do an underscore. So basically there's two ways you can write variables. There's what we call, there's the way I'm writing it, which is called camel case. And this is used for Java and some other programming languages. And it's called camel case because the word has humps. Like this. This is vowel count. Okay. Then there's other stuff that then the other way you can do it is with underscores, which is like this. Which way is the preferred way? I don't care. Nobody cares, really. The official Python way is to use underscores. But what matters more than doing it the way that the language suggests it is that you are consistent. If you're doing camel case, use camel case throughout. If you're doing underscores, use underscores throughout. There's one more convention with variable naming, which is that if you're using all caps for something, that generally means that there's two more conventions that are unwritten. The first is that we typically capitalize if something is all caps, then it's typically a constant, like pi is equal to 3.14159. In some languages, you can make it a type of variable you can't change. And the other one that we'll get into later is classes. If you write a class, which is functions are verbs, classes are creating new nouns in programming. So for instance, if I wrote a class, my object, I would start that with a capital letter to help you know that it was a class. Anytime I'm creating a new noun in the language as opposed to a verb, which is what we typically do. Okay, so vowel count is equal to 0. So now here, let me go ahead and show you a couple ways we can do this. So for letter in text, right? If letter equal to a or letter, and then we could just, this gets tedious, but we could do it like this: 1, 2, 3, 4, 5. A, so U, O, I, E. Right? So there's a way to do that. And vowel count plus is equal to vowel count plus 1. Okay? So that's one way to do it, and probably the most straightforward, like, what do I need to do? What is the most basic kind of thing I can write to do it? There's another way to write that if statement, which is that we can say very simply, is that we can create this list of vowels. And we can say, hey, if letter in list of vowels. Then, and basically we're saying, okay, if the letter that we are looking at in the text is one of these things, the A, the I, the O, or the U, that's another way to do that. And a third way to do that is to do the same thing, but with a string. Makes sense? There's a bunch of different ways we can do this one. Although they all kind of come out to being the same one, you know? Where we just simply iterate through every single letter and look and see, is that letter a vowel? And that check can have a different one. Probably this last one is Pythonic. Yeah, Galan, that would be checking. So what you would have there is that you'd be checking if you had this, right? I'm going to copy what he posted. If you did this as your if statement, then what would happen there is that you're checking if I is the list A, E, I, O, U, as opposed to if it's in the list. You check the in for if you're checking if something is a member of something, like a subset operation in mathematics. Okay. So let's go ahead and take a look at our second problem. Now this one's a bit more interesting. Okay. Number of even digits. Write a function given an int. So here we are given an integer rather than a string or some text. Here you can assume that if this is a number, given an integer, return the number of even digits in the integer. So for instance, if we pass in 254, if we are given 254, you give me back 2 because because 2 is even and 4 is even. If I were, so, and for another example, if we were to call this number of even digits on something like this, 8, 2, 4, 1, 1, 1, 7, we'd be getting back, you'd give me back 3 because there's 3 even digits in there, right? The 8 is even, the 2 is even, and the 4 is even. This is still 3 digits that are even. 8 is even, 4 is even, 2 is even. If I added a 0, we'd be at 4 digits now. Make sense to everybody? So we're just counting the number of digits that are even. Now there's 2 ways to do that. The first is to go like, well, because so here's what you cannot do, right? Let me show you what you cannot just do, which is you cannot do def num even digits, right? This is what I want you to use, but so this isn't bad. Number. You can't do something like this, 4-digit in number, right? And I'll just try to print digit over here, right? Even though I don't want to be printing stuff, but again, just for example purposes, num even digits. Let's go ahead and run this. We start, and I'll get an error which says the int object is not iterable. I was like, what in the world? Why did I get an error before I remembered that? Wait, I'm potentially causing an error. It means you can't use a for loop on a number because it's a number. It's just one thing. So there are essentially a couple ways to do this. One involves using the modular arithmetic, and one involves using converting this into something that you can use that on. So I'm going to give you 5 minutes. I'm going to recreate the rooms, and then we'll go over it, and I'll go over both methods.
Thank you. Oh, Professor, I have a question.
Yes.
So when I call return vowel count, right?
Mhm.
How come when I run the code and I say non-vowels, like hello as my text, it doesn't print out 2? Only when I print vowel count inside of,
Because essentially what you're doing is that unless you actually print it, you're not going to get anything out. You're just giving it data. It says, okay, you got a 3 back, you got a 2 or a 3 back.
Mhm.
What do you want me to do with it? That's essentially what's going on there.
So the return doesn't mean anything then.
The return passes it out of that function.
Oh, so then I could call it. So if I go afterwards, I can then call it again.
Yep. And then so when you call the function, it essentially puts a function in. You can use that in an equation or some kind of other expression.
Mm-hmm.
So since you're getting a number back, you can multiply it or add it to something else. So for instance, if you had a bunch of words that you wanted to do num vowels, that you wanted to count the number of vowels that were in a list of words, you could call that num vowels on each thing rather than having to write yet another function to go over that. You could just do a single operation and say, okay, total number of vowels is equal to, well, what we're going to do is we're going to do a for loop and for word, count the number of vowels in it. And then I'm going to add that to my total number of vowels.
Oh, okay. So then like right now, if I do print non-vowels of hello, when I have it all, nested into each other, then it prints out 2 or 3 or whatever it is.
So yeah, if you want to print something out, what you want to do is if you want to get just a direct answer, there's 2 ways to do it. The first is to just,
Right, that's what I did
do that,
afterwards.
or you can just do like, or you can do val is equal to that and then print out the val.
Print vowel. Yeah, sure. Right. Okay, cool.
Either way
Thank you.
works. Just again, it's your personal preference.
Yeah. Thank you.
No worries.
Professor, I tried to do the return thing, but like when I do it, I don't get anything, like I don't get any output. It's like blank. You're muted. Professor, I think you're muted.
I just realized that. So yes, that's correct. What you have to do is you have to call it like this. Okay. And that still won't give you something. What you have to do at that point is that you have to print out your answer like this. That makes it, or you can do val. And the reason, or you can just store it in a variable like this, val equals num, blah, blah, blah. We're good.
All right. Got it. Thanks.
Mhm. We're just waiting for people to get back. Da, 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 da. So let's see. I got a text. Da, 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 da. So Andrew, the issue with your thing is that you have to, well, let's see, actually, you can't assume that number is a string. We're assuming that it's a number to begin with. Oh, wait. Yeah. All right. So what we're gonna, here's what we're gonna do here. Again, we're gonna assume that number is some kind of integer. Okay. So what we got to do here is that, so let's go ahead and work with this one. All right. So there, so first let's go with the easy way. Well, this is an integer. I can't iterate over an integer, but I can iterate over a string. So I'm going to turn it into a string. This is the simpler solution because it doesn't require so much, but it does require some converting, which can be time consuming and annoying to do. So num, 1 second. Let me make sure my indentation is correct. Was not. Num, or rather I'll call it digit count equal to 0. Number is equal to string number. 4 digit in number. Now what we got to do is that we got to convert it into an integer because we're dealing with a string. Integer is so this will take the digit, which is currently a string, and convert it back into a number. And now we can do a number, a numerical operation. If digit mod 2 equals 0, digit count plus equals 1, increment that by 1. Turn digit count. Let's go ahead and test this. Should be 4 in there. We get 4 back. Okay, so that's one way to do it, to just deal with conversions, which is
Professor, couldn't you also do it so that if you make it, if number, if you have the digit and you don't convert it again, you have so the four digit in numbers, and then you don't convert it back into an integer, and you do if digits equals, and then in parentheses or in quotes 0, 2, 4, 6, 8.
Yep, that's another way to do it. We just,
Hmm.
right, you're suggesting if we left out the conversion step and instead did this, if digit and did it like we did the other one in,
And that's the word that I was missing.
the in.
Yeah, I was like, I forgot how you did the other one.
It's okay. So the good news is that, so that way also works. There's a lot of different valid ways to do it, but basically turning the digit into a string is kind of the way to do it.
Mhm.
All right. Or one of the ways to do it, but it's not necessarily what you can do easily in other programming languages. And also some professors might look annoyed at you because that's not what they intend. Typically they intend for you to keep it an integer. So what can we do then? So this way is a bit harder, but I find it's a bit more elegant, to be honest. So I'm just going to comment this out, or I'm going to comment out this bit over here that I don't need, because we're still going to use the return digit count at the end. So, so what I'm going to do here now is, rather than doing a for loop, I'm going to do a while loop, because he's going to get, because the number of times this numbers that I need to run, the number of numbers I need to check is equal to length of number. And I don't know how long that is easily. I can't length a number and ask how many digit it is. So what I'll do is I'll say, and this should make sense, and I'll walk you through it when I finish writing it, or as I'm writing it. While number is greater than 0, is not equal to 0. And I do need to set up one thing over here. If number is equal to 0, it just occurred to me, if number is 0, then if number is 0, I'm going to go ahead and return 1, because that means if number is 0, we have one digit, right? And if the number is negative, then what I'm going to do is I'm going to turn it into a positive number. Right? Does that make sense? If the number is 0, I'm gonna, because this is an edge case and I don't want to have to think about it. And same with this, I don't want to have to worry about whether or not my thing is going to work on negative numbers. And a negative number is going to have the same number of digits as the positive number. It's just got a dash in front of it, which isn't a digit. So anyway, while the number is not equal to 0, here's what I'm going to do. I'm going to say, so what I'm going to do is that I'm going to go through a number like this, and I'm going to take a look at the last digit. And I'm going to go ahead and say, hey, is that a 0? Is that an even number? If it is, great. Increment my count. If it's not, don't increment it. Regardless, once I read it, I'm going to throw it away. And then I'm going to look at the last digit and I'm going to throw it away. Then I'm going to look at the last digit and throw it away. How am I going to look at the last digit and throw it away? And the answer is by using modular arithmetic and using division.
Well,
So
couldn't you also use the dot pop if you have it as like a string, I guess?
yeah, but I'm trying to do this
Or
all as
list.
a number.
Integer. Gotcha.
So last digit is equal to, and here's one of the cool tricks you can do with modular arithmetic. You can always get the last digit, the ones place of something, by taking your number and modding by 10. Okay. Furthermore, you can also throw away,
Yes, sir.
you can also figure out what the we can, and now, sorry, now that we've, sorry, you can
This
also
is
throw it
from the
away.
Your screen is frozen.
Of course it is. Okay, stop sharing. Yeah, I don't know why it does that. And it hasn't warned me that I want about an update yet, so. So Zoom. End task on Zoom, and I'll see you in 1 second. And I'm back. Okay. So we can also get so we can modulo the number to get by 10 to get the last digit. We can also throw out the last digit by simply taking the number and doing integer division by 10. It's a pretty cool operation. So what I can do is I can say if number number equals 0, specifically if number mod 2 equals 0. If the number is divisible by 2, then digit count plus equals 1. And the reason I want to do it this way is because it gives us a good bit of exercise working with modulo. So if I end the while loop, and again, I get my answer 4. If I put in 2 more numbers over here and 3 more numbers over here, so that should give me, I think, 9 digits there. And this way would, for the computer, because we're doing less conversions, it would be a bit faster because we wouldn't have to be converting and then unconverting and doing all that jazz here. It's a bit more efficient. Could I do the, no, because I need this to run multiple times. I cannot replace this with an else if because I need this to run multiple times. Because what's going to happen is that I keep dividing by 10, and when I'm done, it will be equal to 0. And that's why I have this condition over here. So modular arithmetic is very important, and we're going to see that with the last exercise. So let's do exercise number 3 now. So 3-digit Armstrong numbers. 3-digit Armstrong number is an integer such that the sum of the cube of each digit is equal to the whole number. Blah, blah, blah. That sounds like a lot, right? So the sum of the cube of each digit is equal to the whole number. So here, for instance, 371 and 370 are both Armstrong numbers because what you do is you take each of the digits, you cube them, and you add them up. If you get the same number you started out with, you've got an Armstrong number. Does that make sense? So for instance, to check if 100 is an Armstrong number, what we would do is we'd take 100, we would do 1 cubed plus 0 cubed plus 0 cubed, which would equal 1. So 100 is not an Armstrong number because when we break it apart, it doesn't work like that. Same with 200. 200 would be 8 plus 0 plus 0, which would be equal to, which is not equal to 200. 371, on the other hand, it turns out that 3 cubed plus 7 cubed is equal to 1. So 3 cubed is 27. 7 cubed is 343. 343 plus 27 gives us 370. And then add 1 and we get our Armstrong number over here. And I just didn't put a 1 cubed over here because 1 cubed is 1, you know? So here we want to write a function that tells that it's going to return true or false. Is something an Armstrong number? Does or a 3-digit Armstrong number? Does that make sense to everybody? So let's go ahead and take some time. We're going to take some time on this, and then I'm going to work through in front of you this last problem, just so that we can make sure that we get it all done in time. Okay. And let's go ahead and give you a chance to work on that. And my window with the breakout rooms disappeared, and recreate. This time I'm going to make them, I'm going to do 40 rooms. Recreate. Open all rooms.
Hi, Professor. Sorry, I was in the bathroom.
No worries. We're working on 3-digit Armstrong numbers now.
Joining
So
now. I only missed like the last 2 minutes. I just ran at the wrong time.
no, it's no fine. We're working on 3-digit Armstrong numbers now. So try to work on that on your own. And then I'll go over the solution for that one. And then I'm also going to go over the last problem.
Right. You said you're going to work ahead on that one, right?
I'm going to work on that with alongside you all, just so
Okay.
to show you.
All right. Sounds good.
Okay. Just a bit longer. But I will go ahead and start typing this up. Def is, so when I write a Boolean, I like to do it like this. Def is Armstrong. Basically, I'm writing it as though it's a question. Is it something or not? So number. Okay, so first, we also know that's a 3-digit number, so we can break. So what I'm going to do, rather than converting it into a string like you may have done, I'm going to just keep it as a number. And what I'm going to do is I'm going to break it apart into its component pieces because I know it's a 3-digit number. So I'm going to get the ones place, the tens place, and the hundreds place, which I'm just going to call huns because I only want to use 4 letters. Okay. So how do I break this number out into its components part? Well, I know I can get the ones place from the last problem we did, which is number mod 10, right? That gives me the ones place of the number, right? Make sense to everybody? Now let's go ahead and get the hundreds place, which is actually easier, right? We've got we know we have a 3-digit number, so 3, 4, 5, right? If I want to get the hundreds place, then I want to do an operation that's going to give me 3. If my number is 514, I want to do an operation that's going to give me 5. And if I know my number is 914, I want to get a number that's going to give me 9. It's got to be the same operation for each. Fortunately, we have one. We just simply divide by 100. Specifically, we do integer division. So here, what I'm going to do is I'll do
number mod 100 to get the tens, and then 1,000 to get the hundreds.
that would get you, if you modded by 1,000,
Yeah.
you'd get more than one digit. You get like, if I mod 345 mod 1,000 gives you 345.
And what about divided like to division side?
That's what I'm going to do. If I do two division by 100, then it's going to be 3 remainder 45. And we don't care about, and it doesn't do anything with the remainder. It just tosses it. Make sense?
Yeah.
Now for the tens, right? Well, this one's a bit trickier. The idea here is that we've got a 10. How do I get the tens place? I can't just divide by 10 because that would give me 34. And if I modulo by 10, that's going to give me 5. And if I modulo by 100, it's going to give me 45. Actually, though, that's workable. If I end up with 45 by moduloing by 100, I can then toss out the last digit. So operation is this: throw out the first digit, throw out the last digit. How in the world do I throw out the first digit? Well, to throw out the first digit, that's just, I'm going to mod by 100. To throw out the first digit, I'm going to mod by 100. Why? Well, dividing by 100 gave me 3. And that threw out the last 2 digits. I want to do the other way around, where I want that remainder. So I'm going to do modulo division to throw out the first number. And now the next step is I'm going to throw out the last digit. I'm going to throw out the ones place. And that will throw out the 5. So for 515, again, that would throw out modding by 514 by 100, that would give me 14. And then dividing by 10, that would give me 1. We could also do this the other way around, I suppose, which where basically we another way to do this was that we could just divide by 10 and then mod by 10. Divide by 10 to turn it into to get the 10th place into ones place. Then modulo the by 10 to get the ones place. So there's a couple different mathematical operations to this. Yeah, we could do what we did in the previous example. But I wanted to extract it like this in preparation for the next operation. For the next exercise that we're gonna do. Okay. So now I've got the tens place, the ones tens place, the tens place, and hundreds place. Now that we have those, we know that basically that the a number is an Armstrong number if ones cubed plus tens cubed plus hundreds cubed is equal to the Armstrong to the number. So what we'll do is we'll write basically if one, and so this is one way this is the way you might write it, but it's not the most Pythonic way. I'll show you the Pythonic way in just a second. So ones cubed plus tens cubed. Remember, star is to the is the exponentiation operation plus huns cubed. If that is equal to the original number we had, there's an Armstrong number. And so we'll say return true, else return false. So if the statement evaluates to true, return true, otherwise return false. But I could just skip a step over here. I could just skip that if statement step over here. And this is what's called, this is the more programmatically correct way to do this, which is that, oh, if this is just going to evaluate, then why don't I just simply, return whatever gets evaluated? So if this is, if this statement is true, it's going to be, I'm going to get back true. If it's false, I'm going to get back false. Does that make sense?
Yes, we just made this into a Boolean, right?
Yep.
Ah.
And if you're worried, and if this makes you, and if the lack of order of operations makes you twitchy, you can just throw parentheses on it like this. Okay. Now for the last one, since we only have 15 minutes left, I'm going to go ahead and do this one in front of us. All right. So this one is Holy Digits Batman. The Riddler is planning his next caper somewhere on Pennsylvania Avenue. In his usual sporting fashion, he has left the address in the form of a puzzle. The address on the onto Pennsylvania is a 4-digit number with the following properties. So first off, all the digits have to be different. The digit in the thousands place is 3 times the digit in the tens place. The number is odd and the sum of the digits is 27. So you write a function that uses a loop or loops to return the address where Riddler plans to strike. Now, this is a very useful one to practice on your own, I feel. So I could just leave this for you to do. But I feel like you'd probably want me to walk through this. Is that correct? Yeah. So I'll go ahead and walk through this. So my hint here is in the bottom is saying you want to get the tens, the hundreds, the thousands, and the ones place. So again, what we want to do is break this into the individual numbers. Riddler. Now here we aren't taking a number in because we're trying to figure it out. And again, and here we don't actually need to return anything because we just need to print out an answer. Okay, so first off, we're dealing with, we need to check, essentially what we need to do is that we know it's a 4-digit number. So we need to find out if every 4-digit number, we need to check all the 4-digit numbers to find the one that has this specific property. Okay. So we need to check all the 4-digit numbers. So what I'll do is I'll write a for loop to check all the numbers. For number in range. And I'm going to start at 1,000 and I'm going to up to, but not include 10,000. Right, makes sense? And then I'll manipulate this one a bit to make it a bit easier for me. later. So now that we know that we're going to go through a number, we need to extract all those values from it, right? The ones, the tens, and the huns and the thousands place. Ones, tens, I'm going to call it huns and those. All right, so the ones is going to be the same, but because we're dealing with the 4-digit number, it's going to be a bit different. Right, so let's take a look at the number 5, 4, 3, 2. So for the ones place, I want the answer that gives me 2. So number mod 10 will give me 2, right? Getting the ones place will give me that. And I could just, so one way to go about this is that I could just simply toss away each value as I no longer need it, like this. Like I could do, like this is one way to do it that somebody pointed out, which is I could do number is equal to number
divided by twice to 10.
and then just
Yeah,
keep,
it's like the coins.
and then just keep doing that, but that feels a bit inelegant, but it's effective. So let's go ahead and work on this. Well, 100 was easy to do. What about thousands? Hundreds in the previous one. What about the thousands place? Thousands place is, well, what we could do is that if we divide number by 1,000, that's going to give me 5 here, right? Which is this number, which is great. Similarly for hundreds, what I could do over here for hundreds is I could go number is equal to the remainder of after I divide by 1,000, which would give me 432. And then I could just get the hundreds place out of that, which is divide 100. And that would give, so number divide mod 1,000 would give me 432, divide by 100, that would give me 4. And now what about tens? There's a bunch of ways I can do the tens. What I could do is number divided by 100, which would give me 32. And then I could do number divide by 10. There's a lot of different ways you can work with this mathematically, which is a matter of seeing, okay, how using modulo and division to see how can I throw away the numbers that I don't need, the digits that I don't need.
Would it be divided by 10 or modulo 10 for tens?
Tens, number divided by 100 would give me 32. And then divided by 10 would give me this.
Gotcha.
So there's a couple that you could do it with modulo. There's a few ways to do that. So let's take a look at this. There's 4 conditions. All digits are different. The digit in the thousands place is 3 times the digit in the tens place. The number is odd, and the digit and
I thought it was 54 if you
What's
divide
54?
it by 100. If you use the tens and you do number divided by 100.
oh, you're right. You're right. Ugh. I'm obvious. This is the issue when I type and talk. Yeah, mod would give me 50. Would give me 32. Yeah, my bad. Obviously, I was just testing all of you. You passed, by the way. So
That's the test or the course?
all right, let's go ahead and do this one. So the number is odd. We can actually enforce that without having to check that. If we start out with 1001 and then going up by 2s, this ensures that it's always going to be an odd number. Does that make sense to everybody? So right? Remember, range here is we start at this number, we go up to, but we don't include this number. So this would be 1001 to a 9999. And the third one is our step. Normally, when we leave it out, the step is 1, meaning we'd go start at 1001, go to 1002, go to 1003, go to 1004, then 1005. But if I put in 2 in here, our step is going to be 2. So it'd be 1001, 1003, 1005, 1007, 1009. Okay, so that satisfies condition 3 over here, because we're going to enforce that the number is odd just by affecting the range. So now to do the most annoying part of this. Okay, I happen to know like a one line. Okay, that was weird. I happen to know a one-liner that would do this, how to check all 4 digits are different in one line, but it's black magic. So, and I'd have to talk about operations I don't want to talk about. So what I'll do here is if. So here I'm just going to write an annoyingly long thing to check are all the numbers different. Sometimes it's just easier to do it that way. So if ones is not equal to tens, because we want to make sure that they're all different. If ones is not equal to tens and ones and I could teach you the black magic, but then I'd have to change a question on my exam, which is makes me sad.
You're talking about the final exam, right?
Yes.
Yeah.
And
That's okay.
I'll
We
do
don't mind.
it anyway. I'll show you how to do it. I could change my thing. So ones, tens, so tens, ones, thous, and I might not have time until after class though. Ones, ten, thous, and then if tens is not equal to huns, and I really need to start using the other editor. And then tens is not equal to thousands place, and huns not equal to the thousands place. Okay, so I've checked that in all possible combinations. Ones, the ones against the other ones, then tens against the hundreds, and tens against the thousands, and the hundreds against the thousands. All right. So, and now the next one. All four digits are different. Now, I'm not sure if we could do that because it would compile to ones not equal to tens would probably compile to true or false, and then you'd be checking true or false against the number, which would be true. So that might not do what we would want it to do. Okay, so if a digit is in the thousands place, so test that for me and let me know, but I don't think it would work. Digit in the thousands place is 3 times the digit in the tens place. So thous, if thous is equal to tens times 3. I'm going to share the code after, by the way, so don't worry about madly trying to scramble it down. So thousands is equal to 3 times the tens place, because that's one of the other conditions, right? Is the digit in the thousands place 3 times the digit in the tens place. And then the sum of the digits is 27. Then if ones plus tens plus huns plus thous is equal to 27, print the original number. Which won't run because I just simply did not call it. So let's go ahead and do that. Invoke it. 9837, which I believe is the correct answer. It agrees with what a student sent to me beforehand. So I'm going to go ahead and copy and paste this into your into the chat, which you did not like. So give me a second. Stop sharing. I'm going to go ahead and drop this into the chat window right here. So okay. I was about to see who was doing the feedback. Okay. Yeah, I see your message, Matt. Don't worry if you just watch the recording afterwards. So there, I've sent the file to everybody. Now, if I wanted to do this in one line, what I would do is I'd replace this statement with if set.
You're not sharing your screen, Professor.
Oh, yeah. Share screen. If set ones, tens, huns, thous, if set of that, length of that, equals 4. That's how I do that. And now if I run that, it still gives me the same answer. So what in the world did I just do there? Okay. So there's the black magic I was talking about. How in the world, what, not how did I do it, but what did I do? So I dropped the code in the chat, by the way. And you'll want to upload what we did today. So just submit it on Canvas. So if you need to go, you're dismissed, by the way. I'll just, for anybody who's interested, I can explain how this works. This will be available later. I've got the code already. And it's on Canvas. You submit it onto Canvas. Under this exercise, the in-class exercises loop under module 6 over here. Wait,
Professor, I have a question. real quick.
I was only sharing one thing. Yes, what's the question?
I was taking the quiz last night and my computer screen just froze and I tried refreshing the screen and it just gave me a 0.
Yeah,
Is it
send me an
possible-
email
Okay, I'll send you an email tonight. Thank you,
so I can reset your quiz for you.
Okay, thank you.
So yeah, you want to submit it here under module 6 in class exercise loops.
Another thing is that whenever I download the file from the chat, I like whenever I download it, like downloads, but I can't see the code.
That's weird. Are
Is
you
that-
double clicking on
Is
it?
that on Mac only or?
Try to open it up in idle. Right click and
I
try to
did
open-
it.
and
Yeah,
it
I
doesn't have
tried
any
to.
code in it.
No, it's blank.
Weird. I will, you know what? I'll send it out as an announcement. Okay.
All right, but I don't need, I'm just saying it for the future. I mean, like, I already did it. I followed through.
Mhm.
But
Oh, yeah. Okay. So, okay, let me go ahead, explain this, and then I will take a few demos before I have to run. Okay. So how does this work? So set is so here I put ones, the tens, hundreds, and thousands into a list. So I've got a list of 4 items. Next, I do set. Set is the mathematical set. And what mathematical sets do is that they reject any duplicates. So if I've got 3, 3, 2, 4, it's just going to store 3, 2, 4. And so basically it's a way of me counting the number of unique values in here. And then I ask how many items are in the set. And if it's not equal to 4, then I don't have that many, then I don't have 4 unique values. They're not all different. Make sense? So mathematical
makes
set is one of
sense.
those really
Thank you.
useful operations that we learn or one of those really useful data structures we learn in 2168. Data structures. It's pretty much just used to say, have I seen this before? Or are the things in here unique? Because that's what set arithmetic is really good at. All right, so I'm going to go ahead and stop sharing and stop recording. Stop share. And
Wait, so you could like say convert a